Hi, and welcome to scalable.com. My name is Christoph Wimpler, and in this episode, we have a repeat guest, Simon Eskildsen, who is a site reliability engineering team lead at Shopify. So in the previous episode, which I think was about 2 years ago, we talked a lot about Docker and some of their infrastructure and their scale. But in this episode, we're going to talk about slightly different topics because he's been working on some other interesting developments. Shopify is an incredible platform in terms of scale. They've grown a lot. They have a lot of requests per second. They've had to, they were one of the first major platforms to run Docker in production. So if you're interested in that, definitely check out the previous episode. But I'm super excited about this episode because I think we're gonna have a lot of tremendous information in it. We also have another exciting announcement. And we've got Anthony James here sitting next to me, who is going to now be a new co-host for the show. Anthony is the founder and CEO of linuxacademy.com and cloudassessments.com. And so he has a tremendous amount of technical expertise that I may not have. So he'll be here to ask questions that I may not think of, or he might just run some of the other podcast episodes and I won't even be in those. So be sure to welcome Anthony in the comments below and to thank Simon for coming back on the show for another great episode. So Anthony, welcome to the show, and Simon as well.
Thank you so much. Thanks for having me back.
So let's just dive right in. I like diving in and asking the questions right away. Simon, you had a blog post, and I'll also be sure to link your blog in the link below here because you always just post some really insightful blog posts. But one of your blog post titles is called Shitty First Software Drafts. And in that you wrote, and I quote, Toby, the CEO of Shopify, has mentioned on more than one occasion that git reset -- hard, which blows away all of your work, is his favorite feature of Git. He said that if you can't blow away all of your work and write it again from scratch in 1 hour, you have not found the simplest solution yet. How has this actually shaped your work, Simon, and also just the work of everyone at the organization?
I think that this story is one he told me in my first couple of months at Shopify, and I thought it was somewhat fascinating. He has this very, very deep appreciation for simplicity, and that's really influenced me a lot. And I think this is a great way of talking about it. The origin of the story apparently was that him and the CTO at the time were at this conference, and they were working on I believe the CSV import feature. You know, you have a massive CSV of products or whatever, you import it into your database, and they didn't have the feature at the time. And so I think they stocked the hotel fridge with beer, and then they, at the top of every hour, they blew away all the code with this notion that if they couldn't implement it in an hour, they hadn't come up with the simplest possible way of constructing this software. My favorite sort of analogy to that is that I mentioned in the post is how there's these very famous Picasso paintings where you see a bull or a dog and it's one line, but you can recognize that it's a bull, you can recognize that it's a dog, that it's a penguin. And you just sort of look at that and you say, well, this Picasso guy clearly just did that because he doesn't know how to draw. But you're only seeing the tip of the iceberg. If you look at the whole process and all the drawings of the bull and the dog that came before it, you see that the first drawing is this extremely elaborate, detailed drawing of a bull or a dog, and then there's about 16 revisions. So what I sometimes say internally here is we need to draw the bull again, right? We need to sort of hone in on what is the core idea here. I think that's really, really fundamental because if you do not boil the idea down and really distill it the same way that you do with a shitty first draft, if you don't do that, you're handing over this poor mental model and it can become very difficult to refactor something, take the step back, right? And I think that's really, really important. You would never hand someone the first draft of what you're writing, but you happily hand someone and put up a PR when your code is passing the test. So I really think that our software is kind of cursed and blessed by the fact that we can easily prove whether it does its function because it's very easily to call it done. Whereas writing is blessed and cursed by the fact that it's much more vague whether people understand your idea. So you keep just kind of honing at it. And I think programming needs to sort of balance those two things more so than we do today.
I like that you mentioned that simplicity is actually harder to get, right? So it's kind of like that first draft you're talking about. If you're writing, if you're an author or a programmer or whatever it is, you start with a crappy draft at first and then you have to refine it. But one of the questions I would have to that is, when do you know when it's done, or especially when you have deadlines, right? And you have to hit those deadlines and you've got something that works, but you know it's not the simplest possible way. How do you compromise there? Do you keep trying to refine it? How do you typically juggle that?
I think that's where experience and intuition has to come into some extent, and also What's difficult is that you may look at a pull request and say, hey, that's really complicated. I think that you need to sit down and come up with a simpler solution, but you don't know what it is because that person has more context on it than they do. So you have to trust good judgment. And I think that there are several features that you can consider, such as, what's the deadline? I think a really good one is how many people are going to be touching this code? How fundamental is it? How long is this code going to live? And you sort of have to balance all of those things. And you may not even really do that quite consciously, but I think it sort of all comes down to the sum of those things. Sometimes it really does make a difference to sit there and blow it away every hour until you have the simplest possible thing. If this is something that's really, really fundamental to how the code is going to work, something that a lot of people are going to look at and form a mental model of how something works, then it's really, really worth it, right? But if it's something that is going to be killed a couple of months from now and it's pretty low risk, an area that a lot of people understand, then maybe there's a little bit more room for tech debt, right?
What kind of scale are you guys running out nowadays? I'm curious to compare it versus 2 years ago. What kind of stats can you share?
I wouldn't remember off the top of my head what we were at 2 years ago, but today we're running at about 80,000 requests per second on our Rails app when we hit peak. And yeah, it's been quite a lot, and it's just been compounding every single year. We're running out of 2 data centers now, starting to experimenting a bit with the cloud. But having several thousands of servers, I believe, without having the exact number or really knowing what that is. But there's a lot of workers, because just as a facet of Rails, which just needs a lot of CPU to scale to that extent. But it's working quite well. Yeah, so about 80K RPS.
It's definitely more than last time we spoke. I forget the exact number you mentioned. I don't want to throw out a random number here, but definitely a lot more. And the other thing that we mentioned in the previous episode and talked about a lot is the fact that you guys are running from your own data centers. Here you mentioned you've got 2 different ones. But you told me recently that you're experimenting with a gradual cloud migration. And you also said that you should mold your app to the infrastructure, not the infrastructure to the app. And what do you mean by that?
There's a couple of different things here. I'll talk about the molding first, because I think that's really important. And then we can dive a bit more into the cloud migration and why that's something we've decided to do. So something I'm seeing when we're migrating to the cloud are at least two sort of dangerous patterns. One is that people will be migrating to something like Kubernetes, and they will look at all these shiny new APIs, all these new things that they can do, and all these problems that they can now solve at a much better level. And they get really excited and they start engineering. And this ends up sort of stymieing the actual progress onto the platform, because now we're introducing all of this new risk, right? There is sort of the lift and shift approach to go into a new platform. And then there is the one where you rebuild the entire thing and then you migrate onto that. And neither of those are probably perfect, right? Lift and shift is a hard thing to sort of get through in an organization, because it can be hard to justify the value proposition over time, but doing too much at once can also be a problem. So the other thing that I think is really important is this idea of you need to mold your app to the infrastructure, not the infrastructure to the app. So an example of this can be something like jobs. So in Kubernetes, you configure a graceful deadline. And this graceful deadline is when Kubernetes sends a signal, a SIG term or whatever to your process, you need to be able to shut down in about this interval before it forcefully kills you. So in order to really comply with that Kubernetes paradigm, that's something that you have to do. Now, you can kind of go 2 paths here. You can go the first path, which is, well, okay, I'm just going to configure Kubernetes to have a graceful deadline of 2 weeks, because I have some workloads that can run for up to 2 weeks. But in that case, you're directly violating the paradigm that Kubernetes is trying to set. Clearly, people who run much bigger infrastructures than we have decided that any workload should be able to shut down in this amount of time. If you have a workload that you cannot interrupt for 2 weeks, then the probability of that machine dying, and if you have a lot of those jobs, losing one of those jobs becomes incredibly hard. So in that case, you can build infrastructure that tries to work around the problem, and you can increase the complexity at the infrastructure level, or you can go to the app and fix it at the app level, molding the app to the infrastructure and its paradigms, and actually just not have workloads that cannot be shut down in, say, less than 30 seconds. So, for example, for a web request, if you have web requests that span 2 minutes, you should probably try to work on not having that. And if you have jobs that run for 2 weeks, what we invested heavily, instead of trying to mold the infrastructure to support an app that had these very long-running workloads, what we did instead was we built a new API for people to define jobs, where you define, this is the enumerable or the enumerator, the collection that I want to perform an action on, and this is the action that I want to perform on every single element of that enumerator. And if you have those two things, then you have all of these areas where at an infrastructure level, we can hook in and we can look at things like, for every single iteration, let's check if there was a signal sent, and then we'll shut down gracefully, save the process, and then shove it into another job. And this has had all these sort of compoundingly positive effects, where we now know that any workload can be shut down gracefully. This means that if we went with a cloud provider, we can use instances that can shut down in 30 seconds or less and save a lot of money that way. Another thing is that when we are moving between regions, we know that we can interrupt all the workloads very, very fast without losing anything, which means that we can move between regions very, very gracefully. Another thing that we've done is that between each iteration on lower importance tasks, we can check how the database is doing and sort of use back off and throttle mechanisms automatically. We can also do things such as automatically parallelize the workload based on this collection. And there's just all these sort of compoundingly positive effects that we found. And I think in general, when you do platform level work, it's really important to consider how these good decisions and changing underlying assumptions can have these very positive cascading effects over time. I think that we talk a lot about unknowns in terms of risk and how we may surface something that is really dangerous or can sort of, stymie the project in whatever way. But what we don't talk about so much in platform work is that there are often unknown benefits to something. An analogy that I like to use is that if someone set out to build a 20 or 30-story concrete building, then that just seems very impractical. Walking up 30 flights of stairs, even though you can probably just stack 30 blocks of concrete on top of each other, is just very impractical. It's just much, much easier to build a bunch of 5-story homes and then spread out over a bigger area of land, right? And if you look at all the European cities, that's kind of what happens. But then something happens, and is that someone invents the elevator, and then in the beginning when the elevator came out, everyone was really, really uncomfortable with them, right? They had an operator and there was someone responsible that you could sort of yell at if something went wrong, and over time it built, right? And then when you had places like Manhattan and Chicago and all these cities in the New World shooting up, you had the elevator and you could build these buildings that were much, 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 much bigger. And I think it's the same with infrastructure, where the elevator came first, then the skyscraper. People don't set out to build the skyscraper and then build the elevator. That's too many unknowns on the path to something that you can see as great. So I think as infrastructure developers and working on a platform, you need to identify the elevators in the stack. Another example of this that's perhaps is something like, for example, the Silk Road or whatever, right? You have someone sets out, I want to build, this massive Silk Road, whatever. But they don't set out to say, well, okay, to do that, I need Tor and I need Bitcoins, right? And you don't build all those three things. That's too much. But when Tor and Bitcoin exist, then that kind of becomes a logical next step. Of course, I don't endorse this at all, but I think it's another example of these compounding positive, unknown positives of platform work.
So Simon, Anthony here, based off what you're saying, and we had a little bit of conversation prior to this, I have a few questions for you, right? So one of the things that you were talking about is that Shopify actually works on a little bit of a monolithic architecture on Kubernetes. So my two questions would actually be this: what challenges have you faced with that monolith from a Rails application standpoint? And then actually running that on Kubernetes, what does that look like? As when we look at Kubernetes, a lot of times we think of service-oriented, microservice-oriented architectures because of the sheer nature of how Kubernetes works. And then what challenges have you faced putting that inside of Kubernetes, and how has Kubernetes really enabled you to explore some of those cloud potential migrations?
Yeah. So, there's a lot in that question there. So you may have to follow up on some of the sub-questions there. But
first time co-hosting, I'll get it down.
let's start by talking a bit about the monolith and where we are with that, and then we'll follow up with the Kubernetes there. So, and we're still a fairly monolithic company. I think that's been starting to change as we've grown to several hundred engineers. We are starting to solve problems outside of other apps and are seeing some velocity increases there. But there's also a lot of problems with building these apps that are not a part of sort of what we call Shopify core. The problem is that these Rails apps on day one, they're serving, just because of the network effects of Shopify and all the customers that we have, on day one, these Rails apps are serving more traffic than a vast amount of Rails apps out there. And we'll get a little bit back to that in terms of Kubernetes and how we're leveraging it. But the appeal of putting things in core is that a lot of those scaling challenges has already been somewhat solved. So there's two, to get off the monolith, one, you have to make it really easy to create services. But at our scale, you also have to make it very, very easy that they scale on day one. And at some point, you outgrow Heroku, right? The dyno slider only goes so far. It actually has a limit. And so at some point you reach the limit there where you need to help your internal teams build other services if they're not putting them inside a core. So what we've been doing for a long time is run the main parts of commerce that we do through Shopify in the monolithic application. And the monolithic application is a big Rails app, and most of the core commerce principles are in there, such as how do you do an order? How do you charge customers? How do you do a checkout? Those things are still in there. But we are starting to see and starting to endorse a pattern of building different features outside of Shopify core. So for example, a feature that is built outside of Shopify core is something such as that we call a Shopify Pay or Remember Me, where you go to a checkout on one Shopify store and then it actually remembers you on another Shopify store trying to expedite that checkout. What you're familiar with something like Amazon, where no matter what you're buying and from which vendor, it's the same thing. So that's built as a separate app, right? But the problem is that they are now meeting this massive scale on day one. So what we're trying to do with Kubernetes is, on one part, we have a lot of operational challenges with the monolith, but we also are very, very passionate about trying to create this platform for solving commerce problems faster at Shopify than anyone can do anywhere else. We have these amazing APIs internally, and we need to make it faster to develop commerce at Shopify than anywhere else in the world. That's the mandate of us building a platform on top of Kubernetes. And another big thing of this, of course, is to start migrating to the cloud. Someone made this interesting analogy. I don't know what the source of this is, that perhaps cloud is a bit like what happened to power plants, right? Back in the day, every sort of neighborhood or building or factory or whatever had its own power plant. And today, you just trust the grid and you just hook into the grid and it works and you don't care very much about where your power comes from. And I see that very analogous to where the future of compute goes, in that there will be people who are specialized in providing compute at scale, and they will be fantastic at this. But most people just do not have to build context in that. They just tap into the cloud and they let someone else do it, the same way that we consume power. But there are problems that we are very good at. I don't want Shopify to be a company that is, maybe not yet anyway, but this may ossify over time. I don't want Shopify to be a company that is really, really good at building data centers. That's an opportunity cost for us. Shopify needs to solve contextual problems that helps make commerce better, right? And then, on my part, one of those challenges is, well, we are finding a lot of leverage in Ruby on Rails. We really like working at that, but we need to scale it. So that's still a contextual problem for us because we have a lot of knowledge there. But building data centers, I think Amazon, Google, and Microsoft, they're just world-class at building data centers. And I think that they should continue developing that expertise. And I want the engineers here to focus on things that are more specific to how we run and operate software to eventually help build this platform that helps make commerce better as a result.
So your decision for Kubernetes, and so you're running a lot of on-premises right now, and you're running a little bit in the cloud. So does Kubernetes make it easier to test those workloads? You're running Docker inside of Kubernetes, I believe, as your container engine. Does it make kind of testing and transferring and really testing those workloads easier?
Absolutely, right? Kubernetes is a massive, massive part of this dream to make it easier to build applications inside, right? Kubernetes has these really, really simple APIs, and it sort of abstracts it in, I just want to run this thing, and then a team just goes and figures it out. It has these very, very carefully designed APIs about how you do things, and they're very limiting, but sort of in a very relieving way, because even though the amount of primitives that you have may be limited, they're very carefully considered. They come from people who have run this stuff for such a long time. So I find that that's what speeds us up, right? We now spend time writing controllers and writing proxies and hooking into these different types of Kubernetes is kind of this skeleton, and we're building all these parts that help us move faster. Controllers are fantastic APIs for us to get the majority of our work done. So it helps us move those workloads in that it provides these APIs and this skeleton for doing those things. And it helps us also, Kubernetes is defining this sort of de facto API. And if we want to go multi-cloud and use different providers, this is sort of the standard. The same way that Docker has defined a very, very carefully designed API for how you run containers, I see Kubernetes the same way. It tells us, it also means that people who are coming to Shopify from other companies, starting to work on the infrastructure, they may already be familiar with these APIs. And there's already fantastic documentation out there, so we don't have to duplicate that stuff. And it's just of such high quality, right? We don't have hundreds of contributors that can contribute to that one project, but Kubernetes does. And I mean, that's just reiterating the power of open source, right?
Now, in terms of the actual code base itself, how do you approach refactoring something like that, moving forward? How does that work?
I think we talked a bit about this in the previous episode, but when you move a workload into a new type of infrastructure, in this case, something like Kubernetes, again, you have to mold the app to the infrastructure and these new paradigms. So there are parts of that require a lot of refactoring, right? And I think for Kubernetes, we haven't had to change too much in the app. A lot of these things sort of come as second order effects of just preparing your application for containers already. There's things here and there where you can't really rely on the host being there anymore and stuff like that. But some of the areas where we've embarked on very, very large refactors has been the way that we've been doing sharding over the past couple of years. So we started sharding about 4 years ago, but since we last talked, Shopify is now running multi-DC across multiple data centers. We're moving shards around, moving shops around between shards. We have this sort of very dynamic infrastructure. And as part of that, we had to do some massive, massive refactorings in the code base to support this paradigm. If you're sharded, then it means that every single web request, every single job should only be able to touch a single shard. If it touches multiple shards, it means that it's trying to span connections across potentially multiple different regions that may even be on different continents. That's unreliable. That was a massive refactor. And we're seeing refactors also in terms of trying to scale the monolith for development velocity. If you have a sort of vanilla Rails app and you have hundreds and hundreds of models, you may have callbacks that reach deep, deep into the guts of very, very unrelated parts just because it was an easy shortcut. So we are doing very large refactoring on that front as well to make the code base more maintainable. And when you have hundreds of developers working on the same code base, there's a bit of an art to figuring out how to refactor these code bases at scale. Some of the things that we've started doing are these, I mean, it's not a new idea, but the name is new. We call them shit lists. And what a shit list is that if you are working on some kind of large refactoring or trying to get something done, and there's hundreds of other developers, it is not sufficient to send an email saying, hey, I'm doing this, please don't do that. It just doesn't work. By the time that you're starting to really get progress, a couple tens of new developers have joined who never read that email, who will never read it. And some people may have, archived it. Maybe they were on vacation and just did a rage inbox 0 when they came back. You don't know, but it doesn't scale. But so what we have started doing and what they're starting to be developing a culture internally of doing is that when you are making a big change, such as upgrading Rails, you deprecate a new pattern, but instead of logging to standard error, hey, please don't do this because of this reason, you raise an exception with sometimes multiple paragraphs in the exception note telling you why you shouldn't do this, what you need to do instead, which team's progress you're stifling because of this change, and so on. So now you have this list of, say, classes that violate some principle, something that you're trying to get done. For example, it may be that all of these classes are jobs that are non-idempotent, and you cannot introduce more idempotent jobs. So when you add a new job that is non-idempotent, it raises an error message and tells you this is why you cannot introduce more non-idempotent jobs into the code base. This is a problem, this is a problem, this is a problem. And in the long term, this is to your benefit as well, even though in the short term, it might hurt you a little bit. Then the other team that goes and tries to refactor all those jobs because they're trying to get something else done, they know that the bleeding has stopped, right? They know that they're now communicating effectively. And I think this is really important philosophy to adopt when you're making large refactorings across code bases and with people, is have a little bit of empathy when someone is trying to do something that is stifling your progress by raising a really, really good error or pointing people towards docs that tell them, hey, this is why you can't do this. This is how it benefits you. And this is what you should do instead. You can't just tell people to not do something. You need to tell them what to do instead or who to talk to. And in general, I think when you have so many engineers trying to work on different things with different pressures, different incentives, you need to align around something. And most people will respect a failing test, right? And that really, really, really works well for us. So we challenge we've also seen this pattern where if you change this file, then this team will be tagged on GitHub, right? And that's just some safeguarding that doesn't really work. So we've been able to make very, very large refactoring, upgrading Rails major versions without sort of going two-step backwards if the team was working on something else for a while, with this sort of shitlist approach and just challenging this notion that communicating with errors, communicating with developers just at the right moment, that they cannot do something.
Simon, I read your Medium post, and for those out there, I would suggest looking at the show notes and go and reading this. It's specifically about shit lists. And I'm going to quote you on here. It says, if you own a shit list, you must empathize, with the problems of everyone who's running into problems. If you simply deprecate new behavior and don't offer an alternative, you'll be the source of frustration. So obviously the end result is amazing. You put this process in place that helps your process scale, which is always a struggle for companies. But my question to you is based off of this text inside of your Medium post, was there maybe a little bit of frustrations or challenges actually implementing the shit list? And how did you get around those?
Obviously, this comes out of experience, right? We've had people who reached these shit lists where the errors were, hey, just don't do this. And then you have people coming to you who start losing trust with you because you are just hindering their progress and they don't understand why, right? So we really learned the hard way that, hey, if we have hundreds of developers and we're asking them to do extra work, then we also need to tell them why. And so the errors would say, saying, hey, if you're doing this, then you're hindering the progress of us going multi-DC. This is important, or not going multi-DC, but running in multiple regions at the same time. This is important because of, reason X and Y. So I think that was really, really important, and a lesson that we learned a bit of the hard way. And the same thing happens if you just log something to standard error. Hey, don't do this. People will just ignore it, right? It's just not enough of a nudge for you to do something about it. And you just need to have some powerful primitives there. So
you also put in here, delegating with shit lists is great. Due to tight feedback loop, asking other teams or onboarding new team members becomes much easier. And so one of my questions with that is, as you bring on new team members or you roll out something like shit lists, how do you communicate or get all of your engineers on the same speed, maybe get a new hire onboarded to really understand the value and get buy-in on that?
Yeah. So I think the value of the shit list is typically expressed by whoever owns it, right? So if you have, for example, I'll give you an example. We have this database that we call the master database. Every shop has a little bit of data in there, and these are all shared responsibilities between multiple shops. An example of this could be the representation of an app, or currency rates, or tax rates. These are things that are shared between multiple shops. Now, it's very appealing to just add another table to this global database that is just magically available everywhere, but we can't scale it. And the SLOs that we have around this data store are very, very limited. So we have a shit list that says, do not add new tables and new behavior into this database. And this is why. And so then now we have the shit list of all the tables in master. And then we go and find the teams and we tell them, hey, this table that you have in the master database, as we continue to scale, we add more shards, we add more regions, we add more customers, the availability of this table will decrease. We cannot support this primitive. This is the end of life date, and that you need to remove that table from the shit list. That is, move it either to a different app or shard it by this date. And the reason why is that you will lose trust in your product because it will be less available, right? So you need to create some incentives there, right? And then if the incentive is only there for your team, that may be a hint that either this is not important enough of a shit list to erase, or you just have to do it as a team because you have the biggest incentive to do it. Or the third thing being that you can incentivize from different angles, right? And sometimes it's not quite that false dichotomy between they do it or you do it. It's somewhere in between. But you need to make it extremely clear why does shit list exist, right? So for the delegation, I think it's really great because it's quite satisfying to spend a lot of time trying to figure out how do I define the shit list and how do I automate this process and stop the bleeding. And then you just start removing one entry at a time, right? Converting them to new patterns and things like that. That's a really rewarding. It's really easy to delegate and onboard someone to the team because you say, hey, try to remove that job class from this array of things that are shit listed and see what tests fail. Make the test pass and merge your PR one at a time. And then you learn a lot like that, right? And it's not usually that simple. Often these shit lists are quite high level, right? So getting an element off of it involves some big technical challenges, but it helps sort of stop the bleeding at a high level.
In terms of growth, correct me if I'm wrong, Simon, but in 2013, I believe you had 150 employees, and now the company's at about 1,500 plus. Is that right?
So I think in 2015, we're not 150. That was back in 2013. I don't know how many we were. Oh, okay, that's what you said. Okay.
I hope that's what I said. I'm not sure if that's what I said or not, but I meant 2013, yeah.
Yeah, and today we are at, about 2,000 or so, I think are the latest reported numbers.
Which is huge growth, right? And we've, every company that grows like that, even at a much smaller scale, experiences these problems where they might onboard more developers, more engineers, or anyone really, and the communication processes break down. Now, in terms of development, in terms of what you're talking about here, what are some of the other processes that you guys have been able to put in place that has helped you scale from that smaller size into a huge size now?
Yeah, I think one big thing where these ship lists and patterns that help make sure that you don't stymie other teams' progress on something. A second big investment that we're making is that we're really trying to make the code easier to change. If you have, as I mentioned earlier, these hundreds of Rails models that just communicate sort of willy-nilly with each other, they become really, really hard to understand. And it's just, there's no one anymore who understands the whole code base. So you have to sort of shrink it down. So what we're trying to do now is we're trying to create components. A component is essentially you can think of it almost like a Rails app within a Rails app or a Rails engine, but they're sort of nested, where you have this component and you very clearly define that on either, if you're communicating with this component, these are the APIs. So for example, an API could be that there may be a billing component. The billing component has the API of change the subscription, charge this much on a recurring basis. And the data model behind that barrier is completely opaque to you. The tables behind that component barrier are not doing any joins outside of it. There's no callbacks outside of it. All the callbacks have to be done with contracts to other components. Now, this is to some extent what people do with microservices. If you're creating a service and you're putting this TCP/IP barrier with whatever RPC protocol on top, then you make it very, very clear how to communicate with that other app. But what we're trying to challenge is that maybe you don't need that TCP/IP barrier for everything. And even if you do need it, you can stop just before you're ready to move it out of a separate app. And perhaps there's a lot of value there. So I think a lot of investment in sort of containing complexity is really, really important. But I would challenge the notion that you absolutely have to do services. And just for a third one that I think is kind of fun to mention is that, of course, as you grow to many, many, many hundreds of developers, there's cultural things that you lose, right? If I go down to the water cooler, I don't necessarily know exactly who's there, what they're working on, and I may not even know the question to ask them. So you definitely lose culture when you scale, but I think it's very interesting to consider what culture you can gain. So for example, we've had engineering talks for a really, really long time internally, but when you have hundreds of developers, of course, the people who show up there's so many, and the leverage of doing a really good internal talk is really high when you have a lot of people. Another thing that we've been able to do as a function of scale instead of in spite of scale has been to run these internal podcasts that are only available to Shopify employees, where we talk about engineering, we talk about what people are working on, and the recruiting team is doing this thing where they go around the company and interview people about what is their life story, how did they end up here, and there's a lot of things that you can sort of do because of scale, and not there's a lot of things that you can only do when you have a large scale company. But I think we tend to focus too much on all the things that we can't do because we're at a large scale company.
So I'm going to ask a question. It's not maybe directly related to the engineering standpoint, but you have hundreds of engineers. You have this amazing product that you're supporting. You have tens of thousands or hundreds of thousands of customers. What role, if any, does a product owner or project manager play in your day-to-day lives for your engineering team?
So I can't really speak to that because I'm not quite on the product side. In production engineering, we don't have project managers, and production engineering is the infrastructure team that I'm a part of. We don't have sort of project managers or product managers. I think that may change because now we're building this internal cloud product, the platform that we want people to work on internally. When we're building that, that's a product, right? It needs to have the same way that something like Heroku or Amazon or whatever has a front end and a user experience. So that may change, but for the time being, it's not something that I have a huge insight into. The product teams, of course, have project managers and product managers that look out for creating cross-cutting concerns, talking with teams that have relationships into other teams, such as we just launched an integration. We've launched integrations with different shipping providers, and you need relationships there, and they're sort of responsible for being this hub of communication across the company. But it's not something that I can speak much to, as it's not something I experience very much day to day.
However, how do you structure those infrastructure teams, or even more specifically the SRE teams? What does that typically look like?
I'll give just a tiny bit of history because I think it's useful, and I don't think it's something we've talked much about publicly, but we used to have a classic operations team, and these were people who were just on call for everything, right? And no matter what broke, they were on call. But obviously, that you get beyond even just like a couple of engineers, and things start to break down, and ownership and the incentives don't quite line up, because now you end up having this team that is just by design going to be very conservative about change, and then this team that is very and they're going to be very risk averse. And then you have this other team that will take a lot of risk and just put it into production because they know that they're not going to get on call for it, and they can just ship it on Friday and go, right? So the incentives don't quite line up, which is why this whole DevOps thing kind of happened. Another thing was that we were seeing, you have exponential growth and you can kind of hire, but at some point you can't hire to support that exponential platform growth anymore. So you just need to do a lot of software development to automate. And I think we hit sort of the critical threshold for that in around 2015, where we restructured all of our operations, and sort of we had what we call performance engineers, and we sort of merged the two, and then we created this new team that we call production engineering. And in production engineering, we defined a couple of high-level areas of responsibility. One area of responsibility is what we call developer acceleration. Our developer acceleration is a team that is very much advocating for our product developers, who are the developers that are creating commerce features. They provide a really good bridge between them and infrastructure. So they build things like our CI/CD pipeline. They build our developer infrastructure, where we have these really fantastic tools that build on top of Docker for Mac and has these really cool YAML definitions, super blazing fast, fantastic tool. They build our Docker containers. They do all this stuff. So we call them developer acceleration. Their mandate is to make development better at Shopify. Another team that we call is the traffic team. They're responsible for ingress and egress of traffic, right? So buying traffic from traffic providers and ISPs, announcing our IPs. They're responsible for DDoS mitigation, banning bots, all those sorts of things. So anything that is related to traffic from the customer to the load balancers is handled by that team. Then we have a team that's the data stores team. They're responsible for the relational data stores primarily. We have a team that's responsible for our Redis and Memcache, sort of our queuing and caching infrastructure. We have a team that's responsible for what we call data delivery, which are things like Kafka and Elasticsearch, and sort of alternative pipelines, and into various other facets of engineering. Then we have the team that I am on, which is called the pods team. What we do is we do a lot of sort of cross-cutting concerns and mandate the architecture of especially Shopify core. We've worked a lot on scaling, multi-DC work, moving shops between shards and things like that. And those are sort of the overall way that we're structured. One last team that I think is very worth mentioning and quite interesting is what we call the operational excellence team. The operational excellence team's mandate is this is around 8 people who work full time on trying to create tools and process that makes it easier to be, on call and things like that. So, for example, we have a chatbot and it has an extension to handle incidents. So when an incident starts, you tell the chatbot, oh, this incident started. And it will basically start giving you checklists. After 5 minutes, it may say, hey, do you need to contact more on calls? After 45 minutes, it might say, oh, you may need, if this is a large scope incident, you may need to notify senior leadership about this. After 10 minutes, very early in the process, it might tell you, hey, have you reached out to support and told them very explicitly what the impact of this incident is? Meanwhile, it also helps you keep a log of everything that's going on. When you have messages and graphs coming in from people trying to debug a problem, you can react with emojis, and then that puts it into a timeline at the end of it for a report of what happened during the incident. And this is just a brilliant, brilliant tool that's become such an everyday thing and makes it easy to update the status page and all of those things. And they work on tools like that. Another tool that's worth plugging here is what we call ServiceDB. ServiceDB is this operational excellence initiative where we have this massive, you can imagine it as a spreadsheet, a very fancy spreadsheet of every single app internally. And the columns are things like, do you have it on call? Do you have a CI/CD pipeline? Has this app been deployed within the past month? And all these different checks. And the more checks you pass, the higher tier you are. So a tier 1 app obviously has all of those things and way, way more. And a tier 4 app that's just starting out and running some kind of experiment obviously needs much, much less of this and can sort of need to optimize for speed. But this gives us a report where by director, we can give each director that owns a set of services a score based on how well they're performing and their apps are performing and all of these things. And it gives us this fantastic cultural leverage tool to, we can test things such as Chaos Monkey may in the future hook into ServiceDB and say, hey, here's your Chaos Monkey report. You are not living up to the requirements as a tier 2 application. You need to invest here, or these other apps will start refusing to talk to you because you're not meeting your SLOs, right? So this is just really really powerful tool under operational excellence. So that was a little bit, I really like that team, but that's sort of a deep dive of what the different teams here do.
What I've heard a little bit as we go forward here is bits and pieces of your stack. And I know you're a publicly traded company. I don't know how much you can share on that. And so I'm just going to list off a few of these things that you mentioned and see if there's any other major tools that have been game changers for you that you consider part of your stack, right? So you'd mentioned Kubernetes, obviously, there's Elasticsearch, Redis, Rails. Obviously, Rails is your coding framework, Chaos Monkey, and then internal custom tools. What other components would you consider part of the Shopify stack?
I would say Nginx and OpenResty are just love those tools. I think OpenResty was something that we really started making part of our infrastructure about 2-3 years ago. And I know you want a bit of an overview, but I just want to plug this because this is amazing technology where it allows you to write Lua scripts on your load balancer. And we have written an exponential weighted moving average custom load balancing algorithm that's been phenomenal for us. We've written all of our multi-DC routing on top of this. When we do failovers between regions, we pause the requests. I think DHA talked about this as well on his podcast. But we pause the request to while moving the shard to another data center to basically have no downtime. But we banned bots with these Lua scripts as well. But we found that there's just been, we talked earlier about these sort of positive unknown unknowns and building elevators. And I think that OpenResty has been one of those elevators. It's this thing where we introduced it for 1 or 2 things, and then it's just the amount of useful things that we've been able to build in a tier has just been absolutely incredible. So OpenResty and Nginx is the big one. Another one is we're using Zookeeper for a bunch of things. I think, again, it's kind of like Nginx. It's one of those things that you just kind of run and it never complains and it just works. So fantastic piece of technology as well. We are running Rails. I think we said MySQL earlier as well. We run proxy SQL in front of those. And we're using Kubernetes. We've been using Docker for several years. We're using Docker for Mac sort of locally. We're using Memcache. I don't know if you mentioned that as well for a lot of our caching needs. And I think that just has a well-deserved, fantastic reputation for being a very, very stable infrastructure component. You can see Facebook, how they use it very much as a nail and hammer. And I think that's a good place to be in. I'd say those are some of the main components that we use. I think another thing is that we limit ourselves to the amount of languages that we use. So we primarily use Ruby and Go. It just keeps velocity high because it means that people can very easily move between projects and read the code and things like that. And they tend to have Go tends to be good at a lot of the things that Ruby is not, and Ruby tends to be really good at some things that Go is not as good at. So those two complement each other really, really well for us. Is there any specific part of the stack that you're curious about? I'd be happy to talk about that.
Not at all. In fact, I was just looking for that overview. And I'm going to ask a trendy question, if that's okay. Have you guys evaluated or thought about serverless technologies at all? And if so, what type of role do you see it playing, if any?
I think it's super exciting. Serverless technology is really interesting, right? Because as I mentioned earlier, we have all these apps and they're just reaching really, really big scale on day one. And I think one of the really big things that I want to solve is that I want to make scale such a non-issue so we can all focus on solving problems for our customers and not solving these scaling challenges. And serverless architecture just really much falls in that bucket, right? It's clear that if you follow this set of paradigms, then your thing will just sort of scale endlessly. Considering the staple tier. So I really, really like that. And I'm very interested to see in what sort of patterns that we can start doing now to prepare ourselves for a future where this might be more relevant. But it's not something that I'm betting everything on just yet. Just getting Shopify to run in that would be almost impossible, just given that, it's a Ruby process and it takes, 30, 40, 50 seconds to boot. But there's a lot of interesting things there where I see it very much as the other extreme of auto scaling, right? So if you can already auto scale, which we have problems with, then then it might not work so well. But I'm very interested to see in what kind of patterns can be adopted today that puts us in a good place, not just now, but also in the future where this may be more relevant.
So going back a little bit to cloud migration, as we start to wrap up the episode a little bit here, what's the strategy behind doing that? Because I know when we spoke 2 years ago, I don't think you guys had any plans, or at least not publicly, any plans of trying a cloud migration of any kind. But now it sounds like you're experimenting with it. So what's the thought process behind that?
I alluded a bit to it earlier, right? Like I don't want to be we don't want to be a company that's really good at running data centers. And that's sort of a position that we felt that we were falling into, where we saw a pretty clear fork in the road of, okay, we can invest a lot more in these tools we already have of making it much easier to provision servers and use Chef and things like that. Or we can let someone else do that and then take all these amazing engineers who built this fantastic data center tooling and then make them work on building a platform for everyone to run applications. We want to focus on the abstraction level up from hardware. So I think that's really the biggest factor, that we are we really believe that we can increase our engineering velocity by being on the cloud. And at the end of the day, that's what, that's how we win or lose, right? Is whether we can engineer quicker than everyone else.
And you've also mentioned that, at your scale and with this company, you don't want to be specifically restricted to one single cloud platform. And so being able to find and evaluate some of the tools that allow you to do that, Kubernetes, all those, is very beneficial. So how would you, if somebody else, another, let's say mid to large scale application, is trying to do a cloud migration, what are maybe 3 to 5 tips that you'd give them right now?
The mantra of mold the app to the infrastructure, or not the infrastructure to the app, that just pays off so handsomely later. The second thing being, don't add too many features when you're migrating. Focus on actually migrating. You can get into this very precarious state where you're maintaining 2 different architectures, one on Kubernetes and one not. And if you're in that for a long time, that can really, really, really slow down the amount of progress you can make because you have to do everything twice. I think those are really the 2 main ones. Invest in the things that will work over the long term, and then don't spend all the time migrating to all the new patterns just yet. Hold your horses. If you've been able to survive so far without all these APIs, you can probably survive until you've migrated everything over and done a bit more of the lift and shift rather than the, adorn everything and then move. I think that's either of those extremes I think are perhaps a bit naive, but I would err more on the lift and shift side of that spectrum.
You had a talk at the GoTo conference. I'm not sure which city that one was in. I know they have some multiple ones. I think they have one in Chicago and in Europe and elsewhere, where you talked about the fact that you're working towards performing very low downtime moves of shops between shards and dealing with those. Can you give us a little bit more information into that? And we'll also put a link to the YouTube video for that GoTo talk, so there's more information there. And we've also talked about shards a little bit in the previous episode, but what can you tell us about that?
The main thing that I've been working on over the past 2 years is this basic, what we call the podding architecture, which is to take sharding really to the next level and make sure not just sharding MySQL, but sharding Redis, sharding Memcache, sharding everything, so that we, instead of running one big Shopify with multiple data stores, we run a ton of very small Shopifys. When you do that, you can imagine that the Shopify over here has some stores that are just much, much larger than the Shopify over here. If you imagine all these little Shopifys on a bar chart, you might get something like this. And this is the bar chart. And every single sort of bar is of different sizes, right? So one is like this, one is like this, and so on, so on, so on. So what we're starting to see is that the bar that's like this, the mini Shopify that's this big, has a lot more outages than the one that's like this, right? And this one may just because you have so many of them, there may have been some really, really big stores that take up maybe half of all the traffic there. And perhaps they should have their own little Shopify. Maybe they should be, maybe there's a bunch of shops that could be moved around. But the idea is that we've been really focusing on this year is to move the shops between all of these mini Shopifys in order to flatten that graph, right? The size of every single pod, every single mini Shopify should be as close to the average as possible. So that's been a really big goal, and minimizing the downtime, because you're easily moving, a shop might easily be many gigabytes of relational data, and that takes a long time to insert properly into building the indexes for it and so on. So we've been really investing in a bin log based approach where we just tail the bin log and move the shop, lock it, unlock it. So we can do that in seconds. It's not quite done yet, but that's something that we've invested a lot in. And just in general, this architecture and building on top of OpenResty, and that's what I talk about in the talk of this pods architecture, where we have these mini Shopifys running around the world, and we leverage still that we have a big platform, because if you have a sale, you can steal resources from some of the other Shopifys, so that a disproportionately large store, such as Kanye doing a sale, can steal some resources from some other pods, some other mini Shopifys while they're having the sale, and then sort of give it back to the platform afterwards, and then leave a little bit for Kylie Jenner, who can then have a sale afterwards, right? So that's something that we've really invested a lot in, and just horizontally sharding really, really hard, and trying to ensure that we do not have platform-wide outages, right? That we want to make that impossible.
You also had another talk at SRECon where you were talking about working on very low to zero downtime moves of shards between regions.
Yeah.
And you exercise that on a pretty regular basis. Can you tell us a little bit more about that as well?
Yeah, absolutely. So when we have these little Shopifys, you can imagine that some of these little mini Shopifys, the pods in one region, need to be moved to another region. There may be some kind of disaster, and we do drills with this now fairly frequently. So when we move a pod, we want to minimize the disruption. I think that there are some really important effects to the fact that if you have this stable infrastructure tool where you know that you can evacuate a region, even if you have to do a little bit of low risk maintenance, you just move it out. I think that will over time give much less downtime. So what we've been looking at is, okay, well, how can we have the minimal amount of impact on these moves so we can do them all the time? And so that when disaster hits, they're just regular routine and everyone knows how to do it. You know, that little bot that I was talking about earlier that tells you, hey, have you notified these people or have you updated the status page, can tell you after 50 minutes, like, hey, have you just considered evacuating the region, right? That's where I wanted to get to. So in order to get there, you need to build a lot of trust, and you need to exercise it regularly. And in order to do that, you can only eat so much into your error budget doing resiliency drills. So to do that, you need to have a very small hit on the error budget when you do it. So when we move it, we basically a move boils down to just moving all the stateful resources over to the other region. So letting the database catch up and making the writer in the other region, moving the jobs and things like that. And doing some of this stuff, there's nothing that's writable for that pod, right? The MySQL is readable in both regions for a short period of time while the target region catches up. And during that time, we can't serve checkouts and things like that. And you know, if you sort of zoom out and you look at this from your perspective of, you're trying to do a checkout and you've just entered in your credit card details, you hit pay and it was this expensive order and now you get a 500, right? And there's nothing more dreaded than that. Now you have to call the store and ask them like, hey, did you charge me? Like, what's going on? And they're like, oh, I don't know. Like, it's, you know, you don't want that, right? So that's really bad experience for our customers, and we really want to care about that. So what we do is when the request comes in, doing a move, we pause them at the load balancer while we perform the move, and then we unpause them. So the experience, instead of serving that 500, is instead that the browser is just taking 5 to 10 seconds to load the request, right? Which is not so bad. You may freak out a little bit, but you should not even get to that time. So constantly just minimizing that disruption, I think, is really, really important.
All right, one more question, Simon, to wrap up. Now that you do have a team and you're working with that team, managing that team, what are some of the ways that, one, you motivate that team, and second, you measure either their individual or even the performance of the entire team overall? How do you structure that? How do you manage that nowadays?
I'll just go into two ideas that I really like there on both facets. So in terms of the team, I was reading this book recently called The Power of Moments. And the author of that had written some really, really brilliant books. And it's about creating these, you may remember some of these moments from your childhood where your parents told you something at just the right moment and you just remember this disproportionately better than anything else. And it's just one of these sort of, that's what your bee in the bonnet, right? That's one of these things that just recurrent. And the book is about how do you create those moments. And as part of this, they say, well, it's very important to have purpose. And there's these tests, and I haven't read this study, but essentially, if you have very, very high purpose, or let me approach this from a different angle. If you have very high passion and low purpose, you will only be in about the 20th percentile of performance. Like, passion actually doesn't matter as much as purpose, because you can have high passion, but if there's no purpose, you may be working on the completely wrong thing and kind of just scattering your attention everywhere. But if you're high purpose and high passion, you're in the 80th percentile. If you're high purpose and low passion, you're at the 60th percentile, right? How is it that low passion, high purpose individuals can outperform the high passion, low purpose? And I think that's the responsibility of the manager. So I think that's a really big part of managing a team, is just managing the purpose and making sure that everyone understands why what they're working on is important. How does it affect, in the end, the merchant? How does it affect their customers, whether they're developers or merchant or whatever it is? Whether that means listening in on a support call while there's an incident, so they understand why we don't have incidents and why uptime is important. I think it's really, really important to build purpose. In terms of rewarding employees, I think that, there's a lot of ways of doing this. So I'll talk a bit more about something that I think is more rare and something I would like to see more of. So I think that it's very easy to reward people for being heroes and doing things reactively. If there's an incident and someone does a great job managing the incident for something that they're owners of, we sort of celebrate them and say, hey, that was a great job. You stayed up until 2 a.m. You fixed it. Amazing, right? And it's like, yeah, that's great. But why did that person end up in the first place, right? I see all of those opportunities as that kind of, to me, says that, hey, you made some really bad decisions in the past. And yeah, you had the context to fix it in the moment, but that shouldn't have happened in the first place. What I would like to see more people do to reward performance, both of teams and individuals, is to look at what proactive decisions they've made. It's very subtle, but the way that you can do that I've started experimenting with, is looking at the individuals on my team and the key decisions they've made that year, and then trying to play it forward to now if they've made a different decision. So, for example, this decision of someone on my team made of creating this API to make every job fast changed all these assumptions. And it has these cascading, amazing effects on how we fail over pods, how we move shops, how we throttle jobs, how we parallelize jobs, how we design jobs now. All these amazing effects, right? And so we just sat down and we kind of just entertained for 10 minutes. Hey, what would the present look like if we hadn't done that? If we just taken the short road out? And then you reward people based on that. You do a little bit of role playing of what would the present be if we'd made a different decision. And of course, it works in the other way as well, right? Hey, that decision, what if we didn't done this instead? Where would we be today? But I think rewarding people for being proactive is so important. Black Friday, Cyber Monday is coming up for us. And I think that I'm really proud of the fact that my team is not scrambling to get things done. We're in a state now where it's November, it's Black Friday, Cyber Monday, and we feel that we have a pretty good handle on things, right? And we're not stressed out of our minds. And I think that's something to celebrate. It means that we hopefully have made some really good decisions this year of how we're going to do things for the specific responsibilities that we are responsible for on my team, right? Whereas last year we were scrambling, we were stressed. And that was an opportunity to learn, how do we not get in that situation again? What poor decisions did we make this year to end up in that situation?
Simon, thank you so much for your wisdom and for your time. I really appreciate it. And I really enjoyed this episode, as I did with the previous episode as well. It's always a pleasure to have you on the show. Anthony, thank you so much for joining us on this today as well. If anyone has any follow-up questions or they want to check out some of your content, where and how can they reach out to you? My
blog, Sharding.com, has my talk specifically. If you go to engineeringshopify.com, I believe it is, you will see talks and blog posts from the company. A lot of the things I've talked about today, such as the chatbot, there's videos out there. I think production engineering at Shopify has started doing a lot of talks externally. So a lot of the things that I talked about today, you can find way more in depth than from other talks from people from the company.
You also have a Twitter handle. Are you active on there? And is that something you want to share as well?
Yeah, so twitter.com/Sirupsen, Sirupsen.
Okay, and it's that's the same for the blog as well, sirupsen.com, right?
Yeah.
Okay. Exactly. And then be sure to check out the previous episode as well if you have not already. We'll be sure to link all of these, like the YouTube talks, your blog, and that previous episode below the video, so check that out. Thank you for tuning in as well. And there's one more thing I just thought of. There's this book, I believe it's called Site Reliability Engineering, and it was written by multiple authors from Google. And it's a really good resource that goes into depth into how they run things. And also, you talked about ownership and communication. They talk a lot about that and the processes that they've put in place to help with that. So I highly recommend that you check out that book if that's something you're interested in. Thank you so much again, Simon and Anthony, and thank you all for tuning in. See you next time.